Yeah. Okay, cool. It's working. All right. So before I go ahead, we're going to be starting Year 12 content, okay, which is great. Now, what you'll find in Year 12 is a lot of what you've already completed in Year 11 is actually what you cover in Year 12. It's just building upon the knowledge of that. So you'll notice that this first booklet is just on data, and that's all we're going to work on for these next 4 weeks or so. Just working on data. And a lot of it is just a bit of a recap on things you did in term one. So does anyone remember anything you did in term one? Not at all? Like nothing at all? What about yesterday? What did you do yesterday? You don't even remember that far. All right, there's no point in me asking what you did in term one then, is there? Well, term one, remember we were focusing mainly on data. Okay, we're looking at how to represent data, how you interpret data. Remember, you looked at like box plots, you looked at histograms, you looked at stem and leaf plots, you were looking at mean, median, mode, you were looking at what else? Linear stuff as well, where you drew graphs and a bunch of dots. Okay, that's all related to data. And today's session is just focusing on recapping on all of that. Okay, Jordan, can you close your laptop, please? You don't need it. All right, so please make sure you're following along and writing notes as you go for this. So today we're just going to focus on this bit here, just reviewing on shape, your mean, and your standard deviation. Okay, those three things: shape, mean, standard deviation. Okay, three things that we're just going to focus on. Now, if you can remember on shape and what we learnt about with shape, okay, shape is just talking about how the data, depending on what it might be, so it could be a bar chart, a histogram, or it could be a box plot, what the shape looks like. Okay, where is most of the data, or how is it being spread out throughout maybe a number line. So if you look at this first graph here, negatively skewed. Okay, because actually I'm gonna ask Zaid, why would this be negatively skewed, or how would you describe negatively skewed? Where is the bulk of the data? Would you say? On the right side, good. So the peak or most of the data is somewhere around on the right side. That's how you can look at negatively skewed. If I talked about positively skewed, it's the opposite, okay? Most of your data is on the left side and then it sort of tails off in the end, okay? You can also look at the label there, negatively skewed. You can see that where the data sort of points towards. But I'd just like to see, or the way I like to think about it is where is most of the data? Is it on the left, on the right? Now, if it's neither, then what we refer to that is approximately symmetrical. Tegan, what kind of shape is approximately symmetrical? Look at it. What does that remind you of? What would you say? Anything? Starts with an M. You know, it kind of peaks and then it goes down. You're climbing up it looks like a mountain, all right? That's what approximately symmetrical looks like. Kind of like a mountain, so it's in the middle. Okay, that's what we're looking at with approximately symmetrical. Now, the big focus for this review that we're going to do is on this. Is on data being approximately symmetrical. Okay, that's the focus. Now, the reason being is because a lot of what we'll cover here, so your mean, shape, standard deviation, is dependent on whether or not your shape is on approximately symmetrical or not, okay? All right, a couple things as well that we need to remember is how to put data in a calculator. Let me get mine ready, okay? Have you get your calculators out if you have them on you, okay? Let's get them on so you guys can recap or revise on how to use your CAS calculators. Okay, these things you actually use a lot more in year 12 than you did this year. I'll argue this year, okay, you could actually get away with not having a calculator if you're smart enough, but next year you're gonna need a calculator. Okay, so please have it out. Make sure it's on. Okay, and I'll show you really quickly how to put data in your calculator. Let's see. Yeah, all right, cool. Let's see if I have any data that we can use here. Let's go back to term one data. See if there's any nice bits of data we can use for this. Let's buy there yet. Okay, let's look at some data that we can use to put in our calculator. So remember, a lot of the data that you'll be using, you do need to put in a calculator. As the calculator will do everything for you. Okay, let's see. Yes, okay. Okay, let's look at this data here. All right, let's say for example, oh, that's a lot of numbers, too much numbers. All right, let's look at this. No, actually, no, I don't like that. I need a few more numbers. All right, let's work with these. Okay, let's put this data into our calculator. Okay, I don't know what it represents. That doesn't really matter, but just want to give you a quick recap on how to put data in your calculator. Okay, so home button, remember that. All right, come on, Tegan, let's stop with the lipstick, please. Yeah, home button, new. Okay, you're gonna click new. Now, out of there, you're gonna go to lists and spreadsheets, so the green one, right there, and then there you can put your data in. Make sure make sure your column is labeled. So I could call this whatever I want. I'll just call it data. Doesn't really matter. Okay, or else it's not going to work if you don't put a name for that column. All right, so let's put these numbers in. Now you don't have to put them in order because the calculator will do it for you. Okay, so here, putting a data in, you've got 26. Oh, it's so slow. So my laptop is very laggy. So put those numbers in for me. Just the first set. Don't worry about the one in the bottom. When this works for me. Okay, put those numbers in your calculator. Show you what to do after that. Okay, so 26, 19, 25, 13, 24, 23, 25. Oh, it's two 23s. 20, 28, and then 23. Okay. You should have 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool, 11 numbers. All right, so from there, what do we do? Okay, to put this into, for example, if I wanted to make a histogram or a box plot, okay, this is what we do. We do Control I. Okay, it opens up a new window, and then we go data and statistics. So number 5. Okay, so there's our dots. Now we need to go then on the bottom, so down here, and then click on data, and then it should group the data for us. Okay, that's just your dot plot though. How do I make that into a histogram or whatnot? So we go menu, plot type, histogram or box plot. So we can go histogram. There it is. Okay, there's my data in histogram form. If I wanted to do the frequencies, okay, or the intervals, let's see if this works. Control menu. Okay, bin settings. Okay, if I wanted to do, and again, this is something that we did do in term 1. So if you wanted to watch that video again, just to get a recap on how to do this, that'd be great. But this is talking about the intervals. So if I wanted, for example, intervals of 5, okay, I would go, and my width is the interval, and alignment is where it starts. Okay, so if I want intervals of 5, I go with 5, and alignment is where it begins. So if I look at my data, the first number, or the smallest number is 13. So I might just say, all right, I want to start at 10. Okay, so make that alignment 10. Okay, and then if it does that, go menu, and then zoom the data, and there's my histogram. Okay, if I ask you what shape is this histogram, what would it be, guys? What kind of skew is it? Look at our notes. Okay, let's go. Is it negatively skewed? I would say so, okay, based on what Zaid mentioned, okay. Look how the shape, it looks like it's going to start, or most of the data is on the right-hand side, so it'd be negatively skewed, okay, so it's not symmetrical. Now let's go back to that menu over here. How do I get, for example, your 5-number summary, your mean, your median, your mode, okay? To do that, we're gonna go menu, statistics, stat calculations, and then we'll go one variable, okay, and we go okay. And on the X list, it's the data that we want to work with, okay? Then you go, okay. Now, and there's your data there. So just remember what each of these represent, okay? What each of these symbols represent. So for example, this here is your mean, X with a line on top. So if you look at your notes, it does explain that to you here. Let's see, oops. Okay, that is your mean. That's your mean. Oh, it's already got it there. I will do it here. Mean, and what else have you got here? We don't really need these two. That's fine. SX, however, here is your standard deviation. So that's going to be important for this. Okay. And then over here is the number of numbers. There's your minimum, your Q1, your median, your Q3, and your maximum as well is there. Okay. So you need all that. For example, to make it into, if I wanted to, a histogram, a box plot, then that's what you'd need to draw for that. Okay, and again, you can see the shape of this histogram is probably going to be negatively skewed as well. Okay, all right, so let's do the same with this data. Okay, so we need to draw a dot plot, describe the shape, and then do a couple questions here. Okay, so let's do this. What I want you to do is with the dot plot. We won't be using a calculator for this for now, so it's just going to be a dot plot. So let's draw this. I don't know why my thing is not working. But let's do a dot plot of this data. Okay, so similar to what the calculator did for us, but we're not going to use the calc this time. Okay, so dot plot. Now looking at the data, okay, this is focusing on temperatures, okay, recorded over a number of consecutive days. In a similar location or the same location. Okay, so this is your data. The good thing is it's already been put in numerical order for us, so you don't need to worry about putting it in order. Now the lowest number is 19 and the highest is 37. Okay, so what I want to do is make sure that I include all of those numbers. So on my number line for the dot plot, okay, I might start at 15. Okay, so first number will be 15. And my highest can be 40. So I'm going to go up by fives. So 15, 20, 25, 30, 35, 40. Okay, my number line's a bit too long, so I'll make it shorter. Okay, I want to make sure I include every single value in there. Okay, what you don't want to do, and I've seen people do this, is go 19, then 21, then 22, 23, 24, 25, 27. Okay. That's not the right way to do a dot plot. Okay, you got to make sure your numbers are proper like this. Okay, now from there, we put in our dots. Okay, the first one is 19, so 19 should be just before 20. Next one is 21, which is after the 20. So, and you've got 3. So 1, 2, 3. Then you've got 22, there's 2 of them. So 1, 2. I might put it in a bit closer. Okay. Oh, sorry, cross them out. Then you've got 23. And then you've got 2 24s, so that should be before the 25. Oh, sorry, there's 4 24s. Okay, and then you've got 1 25 in there. And you've got a 27, so that should be more than 26. And then you've got 31, so that's after the 30. And then 36, so that's after the 35, and then 37, which is about here. Okay, so there's our dot plot for that distribution of the data there. Okay, part B. Let's describe the shape. So looking at the shape, a lot of it seems to be on the left-hand side and it trails off towards the right. So what kind of skew is this, guys? Positively skewed, good. Okay, so that's the skew of this, all right? Positively skewed. Part C, what percentage of the days had a temperature above 30? Round your answer to 1 decimal place. So what percentage? Now, again, you've done a few of those questions before, okay, but it's asking how much of the numbers is above 30. So if you look at it, look at the data, there's 3 numbers that are above 30 degrees. So 3 out of, in total, 11. Okay, there are 11 numbers. So to turn that into the percentage, multiply it by 100. Okay, so 3 divided by 11 times 100, and that'll give you 27. It does say to 1 decimal place. So we'll go 27.27, which equals 27.3%. Okay, straightforward. All right, now the next part is question D. Write down the mean and standard deviation of this distribution. Are these appropriate? So we're going to now need to use our calculator for this. Okay, to calculate the mean and the standard deviation. It's the same as what we did previously with the other data, but now it's just this. So again, you can make a new document if you want. Okay, so add a list of spreadsheets, and we'll call this temp. TEMP. And let's put those numbers in. 19, this way. Okay, 19, 21, 21, 21, 22, 22, 23, 24, 24, 24, 24. Actually, did we have, I think we had more than 11. Sorry, my bad. That 27% would have been wrong, but anyway, let's fix that up there. 25, 27, 31, 36, 37. Okay, let me quickly fix this because we had, sorry, we should have 16 numbers. Okay, so this should be out of the 16. So 3 divided by 16. So that's times 100 would be 18.8. Okay, easy. All right, put those numbers in. Pretty straightforward. Okay, how do you do your 5-number summary, your mean, median, mode? Remember, menu, statistics, stat count, 1 variable stats. Okay, and then put your data in here as whatever the data you're looking for, and there it is. Okay, you're only looking for the mean and the standard deviation. So you're looking at this number and this number here. Okay, those two. So that means the mean is 25.06. Okay, so D 25.06. And then for our standard deviation, we'll just call that SD. Or actually, some people will write SX as well. So let's just do that. Is 5.26. Okay. All right, now, question. Okay, when we get to question D, there's another part there that says, are these appropriate measures for center and spread in this distribution? So one thing to keep in mind when he asks you for that is if your data is skewed, these are not appropriate. Okay, your data has to be symmetrical for mean and standard deviation to be appropriate. So what you would say for question D is standard mean and standard deviation are not appropriate measures of center because the data is skewed, or the data is positively skewed. Okay, so for your data to be, for mean and standard deviation to be a proper measure of center, it has to be approximately symmetrical. Okay, it has to be. Okay. And that's basically it. I won't go through this one because it's probably going to be similar, but then the data is going to be symmetrical for this, okay? So only works if your data is approximately symmetrical or exactly symmetrical, okay? So that's when you can use mean and standard deviation, okay? Any questions with that? So pretty straightforward. All you're doing, okay, for the exercises is you're drawing your dot plots, you're describing the shape, and then you're telling me whether or not mean and standard deviation is appropriate. Okay, and you might be using finding percentages for some of those shapes, but that's all you'll be doing for today's session. If you've done that already,